Hello and welcome back to my channel again, which is Teacher Cool. So in the previous video, we were talking about the new strange particles which were discovered in the photographic pictures of the cloud chambers and how we studied them under controlled conditions in those accelerators and chambers only. And after we studied them, we were talking about sorting of these particles, like making a tabular form and rearranging them depending upon their charges and their masses and the properties shown by these strange particles. So let's start again without wasting any time. So here we are again with the particles sorted in a tabular form. So right now we have proton, neutron, electrons, then we have our neutrinos, then we have the muon, pion and kaons. These were the all particles, except from these one particle was which we called it as virtual photons, which we cannot detect directly or indirectly, so we will not study about it and we'll treat it as a normal photon only. So the first particle is a proton. It will be denoted by P, having a positive charge. Its antiparticle would be antiproton, which will be P bar. The charge will be negative. Rest mass remains the same for particle and antiparticle, and it was a basic property of the antiparticle also. And the proton will show the strong interactions, the weak interactions and electromagnetic interactions. The second particle is a neutron having zero charge, so the antiparticle would be antineutron, again neutral. The rest mass, which is approximately same as the protons, slight difference. The only difference here, it will be the strong and weak. Why? Because neutron doesn't carry any charge, so it will not show the electromagnetic interactions. Next particle is electron, negative charge. Positron will be its antiparticle, denoted by E negative and E positive, having the positive charge. Rest mass, I already told, the rest mass of electron is 0.511 and electron is a charged particle, so it will show the weak interactions and the electromagnetic interactions. It will not show the strong interactions. Neutrino, again a neutral particle. Antineutrino will be the antiparticle, zero mass. It is a massless particle and it will only show the weak interactions. Then we have the muons. Muon is a negatively charged particle, so its antimuon would be positive charge and rest mass is 106, weak interactions and electromagnetic interactions, obviously since it is a charged particle. Then we have pions. Pions we can have three charges, which is negative, neutral and positive. So these are the charges. The antiparticles would be reverse, having positive charge, zero charge and negative charge. So the same way. Now again, you can see the charged pions have almost or actually the same rest masses, while the neutral pion will have slightly lesser. And since these are charged also and these are neutral also, so in case of charged pions, they'll show electromagnetic interactions, whereas strong interactions for the neutral one. Similarly, kaons, we have three charges, the anti-quarks, and quarks will be its antiparticles. Charges will be opposite of this. Then again, the charged ones have the similar rest masses, but here the neutral one will have slightly higher rest mass. Again, the positive and negative charge kaons will show me the electromagnetic interactions, whereas the neutral one will show me the strong interactions. Now, when we say we need to classify these particles on the basis of some properties or some interactions, so we say in order to classify all these, we basically or we broadly divide them into two categories depending upon their interactions. You can very well see here that I have already written the interactions here in the green pen, where the middle three particles are not showing strong interactions. Otherwise, all four other particles are showing me strong interactions. So the first thing which comes into my mind is hadrons. The first category are the particles and antiparticles interacting through the strong interactions. So कौन से होंगे? Proton, neutron, pion, kaons. four particles and their antiparticles, and then these particles basically interact through all four interactions. You can see strong, weak, electromagnetic, and since they all have the masses, very high masses, they will also interact through gravitational interactions. So I say these basically interact through all fundamental interactions, strong, electromagnetic when charged, apart from the protons, except the protons, hadrons decay through weak interactions. This is one major point. Then the second category is my leptons, the green ones, where I'll say particles or antiparticles that do not interact through strong interactions. So it is electron, neutrino and muons. These basically interact through weak and gravitational and electromagnetic if charged, that means electron and muon, right? So these are the two broad categories of these particles, which are hadrons and leptons. Leptons will not interact through strong interactions. That is the one major differentiation between them. Now when we say these are interacting through some interactions, some energy must be involved. So how do we study the energies carried by these particles? So basic is, we have large hadron colliders where these hadron particles, which are proton, neutron, pions and kaons, where what we basically do is we make use of a collider. There is a you can say ring shaped cylinder which I have drawn here. In these colliders, we make these particles collide at sufficient or very high energies, and we study or observe these results, and on basis of these results we make use of conservation laws and we reach to some conclusions. So what is happening here? We have a tube like you can say a collider, ring shaped accelerators we call them. Then we have a number of rings inside these colliders. What do these rings do? These rings basically boost the kinetic energy of the charged particle at all levels. It is a uniform booster. So there are multiple rings which are boosting the kinetic energy of these hadrons at every point. Then when we say we are boosting the energies, then as the speed increases, since these are charged all particles also, so they will deviate or they might deviate. So keep them, their deviations from in check. What we do is, with every ring there is a magnet attached to it which will prevent deviation. Wherever the particle will deviate, this magnet will revert it back to its original path. So this way we get a straight lines, or we get the desired path or trajectories of these particles, and then they collide. Now when we are talking about two hadrons colliding, what is happening before the collision? We say the total energy of the particle and its antiparticle is rest mass दोनों का plus the kinetic energy दोनों का. This is not the mathematical multiplication but the denotation. This P plus P bar is for the both the particles. Then these are the reactants, but after they collide, total energy will be, this is the products, again the rest masses and the kinetic energy of both the particles. Now by energy conservation these should equate. So we say by using the energy conservation laws we come to a result that the rest energy of the products which are formed, the rest mass energies of the products formed will be the total energy of the reactants minus the kinetic energy of the products. So we get this relation, and from here what is its significance is, I can give you an analogy. Like if I'm saying I have a proton which is colliding with some other particle, or say let's say there is a proton having 2 giga electron volts of energy and it is colliding with another antiproton having 2 giga electron volts of energy, then the product which is formed will have the total energy of 6, not 4, which should be 2 plus 2 equals to 4, but it will have 6 giga electron volts of energy. Why? Because we left the contribution of the rest masses. So I say for a proton, I say if 1 giga electron volts is its rest mass energy, then 1 giga electron volts is the rest mass energy of antiproton. These two will also add. So I get it will be 2 plus 2 plus 1 plus 1, where 1 plus 1 comes from the rest mass contribution, and the total energy of the product formed will be 6 giga electron volts. So this is my sorting of the particles, where I have studied these particles, I have discovered them, I have observed and calculated their charges and their masses and the modes of their interactions, whether in the origination or in the, you can say, decay, and I have tabulated here. So this will be the final table. Then we talked about the broad classification in terms of hadrons and leptons. Then how do we make them react, and what is the significance of rest masses energy in overall collisions. Now the next topic are baryons and mesons, which again will add to this list, and then finally we'll be making our family chart. So for this video, this is all. Till we bring back again the next topic, which is the baryons and mesons, and finally reaching towards our family tree. So till then, stay tuned. Do let me know your doubts. Do let me know your reviews on my videos, on my way of teaching in my comment section. And also do not forget to like, share, subscribe to my channel, which is Teacher Cool. Thank you so much.